of 1 over x and a g of, anybody? X plus 7. Very nice. And when I look at this, remember I told y'all yesterday, my strategy is to kind of approach this by way of my foldable and not visualize, it's the wrong word, try and pinpoint which parent functions are present here. I absolutely see reciprocal going on with the 1 over, and then there's the linear identity function down here at the bottom. So that's how I'm going here. Armando and I were talking, like, I couldn't really think of another pair here to, like, provide additional support unless I get, like, really, really creative, which is kind of strange. So if you're longing to know if there's something else that would work, I could maybe, if I was feeling fancy, make this like 1 over 2x and make g then 1/2 x plus 3.5.
That's too much.
If I want to get fancy, I can. I would not expect anybody to be able to come up with something like that. That's just me, like, trying to be a little booger. Okay? And you don't need to think that. But this is standard and fair game. Absolutely. Okay, now I want us to move back to where we were finishing off yesterday. Did we finish our example on page 76 yesterday? I don't remember.
We just put in the chart.
76.
Yeah, that's steps.
Oh, we didn't get to do any model.
No.
Okay, cool. So let's go to 75. Thank you for reminding me. I always forget where I'm at. And am I filming right now?
Yes.
Am I live?
Yes.
Hi. Okay. Thank y'all for adjusting with all of that going on. Okay, so what we talked about yesterday is the fact that the last major skill of the unit is going to be to compute inverse functions. We did a lot of this, yes? What's the word when I do this? Switch. And it means switch everything, right? We gotta switch everything. First things first, step 1, which we recorded in our table yesterday, is to verify that our function is 1-to-1 using the horizontal line test, and then determine the domain and range of our function. In a minute, when we do another example, I will let you do this part with your calculator. For this particular function, I believe that we can all graph this by hand. The square root of x minus 4. It's Friday and I'm hyper. What does the square root function look like? Daisy.
Like the little curved line.
Yes, this one, right? It always stretches out. I don't know what that muscle is, but that one. And this square root is going somewhere. Daisy, why right?
Because it's in the little house, so like you're gonna be defiant and go to the right instead of the left.
Beautiful. Inside the house, I do not do minus, I do plus, and that means I go right. So everybody go to 4, 1, 2, 3, 4, and draw that square root. And if I were to project a horizontal line anywhere on that graph, how many times would the line hit? Once. Which is great news. Verifying that the function is 1-to-1 using the horizontal line test means, does a horizontal line cross just one time? If so, yes, I have verified what I need to. The words I want to see is that f of x is 1-to-1. And once we verify that, all we got to do is find domain and range. I firmly believe that if we have a picture here, most of us in the room can appropriately find domain and range. What I'm still a little concerned with is if I didn't provide the picture, if you could find the domain just given the equation. So that's what I want to review really quick before we move forward. And we'll confirm it with our picture, but you should be prepared to do this without a graph as well. Square root of x minus 4. So what we talked about in the past is that to find the domain of a square root function, like x minus 4, I focus on the radicand, which is what is underneath the radical. I rewrite that, and I'm remembering that in pre-calculus I can only square root positive numbers. So I set up a little inequality that indicates greater than or equal to 0 and solve. This is best case because there's just one algebraic move that I need to make in order to isolate the x. Emma, what's that move? Add a 4 to cancel the minus 4. So it looks like then x has to be greater than or equal to 4. Many of you, if you rewind to the quiz that I had you take the other day, remember that bonus question? I asked you to find the domain of something that was a radical. And there were several of you in here who did this. And I was like, yes, I'm going to give them an extra point. And then they kept going. I was like, no, stop. And they wrote domain, all real numbers except this. And that killed me because we only use this form if we have a rational equation. If we have a radical, like what I have right here, I have my domain. I want x's that are greater than or equal to 4. Is that not true on my picture here?
Yeah.
Starting at 4, ending where?
Infinity.
Which is the same as x's bigger than or equal to 4.
What if it was under a 1? Like it was a fraction and the radical was under the 1. Would you still put the answer as that, or like would you use the except?
Great. So if it were something like this, is this what you're asking me about?
Yeah.
Beautiful. The only adjustment I would make here is that I could not include the 4. Because if x is 4, what happens to my denominator? 4 minus 4?
Cancels out.
0. And I have 0, which I know is never, ever, ever allowed. So I would have to do in this case is start by finding my domain with the x minus 4, the term under the radical, but instead of a greater than or equal to, I would just put greater than. And my answer, because the radical is there, would not have those words except or anything like that. Only changes there's no equal. Great question. Good. Most of you would probably write that as 4 to infinity. You could also write the inequality x greater than or equal to 4. Those meaning exactly. Okay, moving right along. Let's use our picture for this one because we haven't talked about how to find the range yet by hand. We'll do that next unit. How low does this graph go? How high does it go?
Infinity.
It goes to infinity eventually, all right? So my outputs for my y and my range values then are 0 to infinity, which we can anchor that in our picture.
What if you didn't have a picture?
I would only ask for domain. At this point in pre-cal. Maybe later in the year I would ask for range too. Okay, now step 2. We wrote this in our table yesterday. We're going to try it out. This says if needed, replace f of x with y. That's needed here because I start you with an f of x function. I'm going to write what we have, but instead of f of x, we'll go with y equals square root of x minus 4. And now we will exchange variables. Another word I could have used there is switch our variables. So this becomes x equals square root of y minus 4. The only thing that happens is the x and the y trade places. So far, so good? Step 3 is the fun step where we do the most math. Using legal algebra, solve for y. Here's y. I need to get rid of all the stuff around the y. I need to start from the outside and work my way in, which means that square root's got to go. How do I cancel a square root? Oh, good. Lots of you stole Daisy's. We square. Very good. Over here, the square root and the square are gone, so I have a y minus 4. On the left-hand side, x to the power of 2, I don't know why I traded colors, is x squared. Add 4 is the last appropriate move to get y alone. Beautiful. I see a minus, I do a plus. And it looks like y is x squared plus 4. You'll notice step 4 says, congratulations, you have found the inverse. Simply